Ja, da bin ich wieder. An dieser Stelle nochmal vielen Dank an den Herrn Jung und den Herrn Alpha für die Präsentation und die spannenden Einblicke in Ihre Business Intelligence Anwendung mit Pentaho. Ja, dann sind wir beim letzten Vortrag. Entschuldigung für die leichten Verzögerungen, die wir haben, aber jetzt haben wir auf jeden Fall noch ein sehr spannendes, weil auch sehr, sehr aktuelles und modernes Thema. Der Vortrag nennt sich Advancing from Self-Service BI to Self-Service AI, also Artificial Intelligence, und wird gehalten von Vishnu Krishnan, welcher AI-Architekt bei Data Robot ist. Und der Vortrag wird auch auf Englisch sein, sodass ich jetzt auch wieder auf Englisch wechseln werde. Hi, Vishnu. Welcome to Pentaho User Meeting. Great having you here.
Yeah,
Great
thank
to see you again. So I'm really looking forward to your presentation. I just mentioned that we will switch to the more analytical part of the data universe, and you will present some really modern topics like MLOPS, AutoML, and how to do this with Data Robot on the one hand side. And on the other side, I know that you have some history with Pentaho, and maybe you can explain it at the beginning of your presentation. And you will show how this can benefit, or how Data Robot can work together with Pentaho in a good way to build end-to-end data pipelines and to leverage a good machine learning or a data science approach.
Yeah, and we had the previous presenter speak about self-service BI, right? So it's a good segue into my presentation, and we're going to talk about or even see how perhaps you can do self-service AI. So that's a perfect transition. About timings, Stefan, how much time do I have now to present?
30 minutes.
Okay, okay, perfect. Thank you.
Yeah, okay,
so let me start. So first of all, introduction. Yeah, as Stefan said, I have a history with Hitachi. So I worked for Hitachi for 7 years. Was based in Finland. I see Jerome Renner is on the call today, and he was my colleague in Germany. And I know I had heard a lot about it-novum and how they were successful in Germany. So a few months ago, we had this chat with Stefan and Philip Heck, and we were trying to pursue a prospect together. And then when the Pentaho user meeting was announced, Philip thought it was a good idea that I present. And so I said, why not? Nice to meet old friends. And so here I am. So I'm based in Munich. I work for a company called Data Robo, and we kind of develop a software, a platform, which allows you to do machine learning or artificial intelligence, and in a very intuitive way, lowers the barrier for entry. And that's what I'm going to present and demonstrate today. So I'll try to be quick and light because I know I'm between. Sorry, I need to present the right screen. Okay. Stefan, do you see my screen? So I hope you can all see my presentation. So the key takeaway I have from today's presentation, because I know a lot of information has been shared, so I want you to be focused. And the idea is to kind of give you a glimpse of how auto machine learning, which is in short called AutoML, and machine learning ops be harnessed for you to develop self-service AI in your organization. So we have a lot of organizations already in Germany adopting this technology, like large logistics provider or large automaker. They are trying to train their analysts and also data scientists to accelerate the adoption of AI in their organization. So that's the key takeaway I want you to have from this session. And I'm going to illustrate the comparison. So if you look at traditional BI that we saw maybe 20 years ago or 15 years ago, I mean, the dates can vary. We saw that business would have an idea that data would benefit them. They would come to a BI developer and say, hey, could you help us build some dashboards? And the BI developer then would go to the IT department, and say, hey, could you help me extract the data, load it into a data warehouse, then present it on a BI dashboard, or even embed it in some PDF. And so many months later, if all of this is successful, several revisions happen, and then you get a dashboard. Back in those days, the dashboards were just on someone's desktop, and perhaps they would extract the images or the visualizations and embed it in some report and present it. So the refresh rate was kind of very, let's say, seldom. But then we see today, for example, we see that the business users can themselves build dashboards. You know, the BI tools have become very mature. We saw like so many of the presenters were adopting C tools, which was not the case even 10 years ago. So we see like a lot of advancement in this area of business users developing their own dashboards. So once they have ideated and they have seen that there is value in a certain data set or a certain business case, then they can actually go to the BI developer and try to productionize their dashboard. So as we saw in the previous presentation, the Daniel and Lucas, they have actually embedded their dashboards in the intranet service. So of course, those things take time, but the ideation is already very easy with self-service BI. So the BI developer also has a lot of tools right now, like they have data catalog where they can find the data sets. They can use visual data prep like Pentaho or PDI, and then they can use self-service BI like C tools or Tableau or Power BI. And they can easily dish up a very nice dashboard in a couple of weeks or even a month. So the acceleration of data adoption of BI in business has been phenomenal in the last few years, especially with the advent of cloud technologies and modern data warehouses, etc. So the question is like, do we have a similar path to data science or machine learning and artificial intelligence? And that's what we're going to explore today. Are the challenges the same or are they different? So of course I post this funny meme because there is a lot of overlap between analytics and data science, but there is also a huge difference in the needs and the requirements that we see in the field. So you of course need analytic skills, but then you also need some specific skills to advance in data science. So what does data science look like today? I speak to a lot of customers and prospects as well across EMEA, and I see the maturity levels are of course very, very different. Like you have some customers who are very high at the high end of the maturity curve. Some are just starting, some have never adopted AI. So we of course see a mix of customers, but typically what I see is that the business has identified the need for using data science or machine learning in their processes, right? That's how it usually begins. And then typically they hire data scientists who have some industry knowledge, and they say, hey, could you build us some models, right? So that's what usually happens. And these data scientists are embedded in their business practice, and there's a constant exchange of, let's say, the technical know-how of the industry and the skills that a data scientist typically needs to have. So that's another topic of discussion. Like the definition of a data scientist is pretty large. You can see this Venn diagram on the internet where you see what skills does a data scientist actually require, and it's a huge list, and it sometimes makes you think that it's easier to find a unicorn than to find a data scientist. But typically, what does a data scientist do? Today, the toolkit that they have is a notebook-like environment, like you might have seen Jupyter or some other kind of notebook environment, and they develop code. Coding is a very, very essential skill. So if you look for courses on machine learning today, like you cannot find a course which does not have the requirement to code. And so what they do is they take the data set, they play around with it, they do exploratory data analysis, and then they finally, the result, a couple of months, if you're lucky, or even a year, is that they have an artifact, which is a serialized model, and they have some plots on their notebook. Now, this is great. Like it might be that they have found the right modeling techniques, they have processed the data correctly, but it's very hard for business to understand these plots because they're very technical in nature. So the model never goes to production as long as the business is not confident about this model, right? So there is not much explainability that can be translated to a business person, and that's what's lacking. But let's assume the business person is very technical as well, and they understand these plots. They say, wow, like, we have a winner here, like, let's put this model in production. The same challenges that we saw with BI 20 years ago ensue also with AI now, or machine learning. So the data scientist says, okay, here we have a model that is great. Let's put that in production. They go to the DevOps engineers and they say, hey, here's my model, put that in production. Now the DevOps engineer has a variety of tools. They have containers, Kubernetes, they have CI/CD pipelines. They have to wrap the model inside an API or use it on a distributed platform like a Spark cluster. So there is a lot of complexity there. And plus you will see that different business units now will have different data scientists. They use different languages. They might use Python, they might use Java. So there's a lot of complexity for these DevOps teams to handle. And as a result of that, they take a long time to put the model in production. So let's say they take 3 months and the model is in production. By now, the business case might have already changed because 3 months is a long time. And the model is making predictions, but nobody in the organization then knows whether those predictions are accurate or whether there's a data drift happening, or if that model is any more reliable, because many of my customers, they do not monitor their models that they have deployed. So they're basically relying on some kind of trust to assume that the model is making predictions, or they are waiting for the business to provide feedback on the predictions and the accuracy of the predictions. So that's the gist of the problem. I'm going to just show you the current situation where if you use certain software or certain tools. In this case, I'm going to demo the software that my company has created over the last 12 years. And then we will see how this process can be made easy and how self-service AI is already a reality today for many organizations. So transitioning into the demo, let's make it full screen here. So what happens typically is that you assign a project manager, or you are the head of, let's say, analytics, or you're head of data science. You sit with a list of use cases that you think are the use cases which benefit from machine learning or AI. And the software has a intuitive feature where you can actually ideate. So this is just a simple form where you can enter your use case. You can assign a value to the use case. So you can say, okay, how many decisions are made? What's the cost of a wrong decision? So for example, or this could be a machine. So let's say you want to do preventive maintenance, and every 3 months you replace the machinery without any predictions. Let's say that costs you a certain amount of euros. So you can make those decisions. And typically the best use cases to pursue are the ones which have a high business impact and which are also highly feasible. So of course, you cannot pursue all the cases that you have, because data transformation, storing the data, gathering the data, etc., is all a challenge. And again, that's where tools like Pentaho come into picture, because this kind of software doesn't do the heavy lifting for you. But you typically have to ideate and figure out the use cases that have high feasibility and high business impact. So that's how you do. And then you can track the project through the various stages of the life cycle. So you can go, check what's the stage what's happening when the data is being prepared and it's being modeled and it's being validated. So this is basically just a visualization for a project manager or a manager who's driving the initiatives inside the organization. So today, let's look at like a use case. So we have a pathfinder here where we have a lot of use cases documented because we interact with customers of almost every industry. And so we're going to look at one of the use cases, which is the likelihood of a loan default. So I picked a very easy use case. It's a classification problem. You can click on this and you can see the business problem described here, and this is available to everyone across the globe. You can also see the technical implementation of this, and you can see that we have a data set with a certain amount of features in it. So these features represent the people who have taken loans and have repaid them or have defaulted. right? So of course, you can see that the person had a car, they have a certain age, or they might have a job title as well. So we're going to make the algorithms try and detect the patterns in the data set that we have, in the historical data that we have, to make predictions on the applicants that come in the future. So to do that, what we have to do is very simple. We go to the main user screen. In this case, you can connect to any data source. Of course, we have a certain list of data sources. Anything beyond this would be basically delegated to a data integration tool like Pentaho. But we also have direct connectors. So let's say you have the data in the data mart. That would be the typical data source for such a project. In this case, I'm going to just use the local file option, and then I'm just going to use a training data set, which has the records, historical records of all the lenders who took loans from the lending club, and we're going to try and see if the software can actually learn from this data set. So what the software does, it uploads the data. On the right side, you can see that it will perform automatic exploratory data analysis, and you'll see in a second what that means. But what happens at the later stage, after these three steps are completed, in the interest of time, I'm going to switch directly to that. So you will see that the software has done some analysis of the data set that you uploaded. You can see that it has identified the data types. So you have numerical, you have categorical, you even have text in here. And why this is important is because there is a lot of pre-processing that needs to be done for the algorithms to handle this type of data. So you need to do a certain pre-processing for the categorical, certain for the numeric, and also for the text. It would be different. And the data types are not limited to these. You can have geospatial data, or you can have images actually combined in the same data set, which then can be input here as well. So what is interesting is that you can actually do a very quick data quality assessment. You can see that certain columns have excess zeros, they have outliers, and therefore you can immediately start to try to fix this by going back to the data preparation stage. So you use PDI, for example, to fix these issues, or you can ignore those concerns as well. So what it can also detect is what we call as the data leakage. So some fields might not be present when you make a prediction, and this tool can automatically detect if there is very high correlation between the field and the target variable. So what's the target variable? The target variable is what we are going to predict. So in this case, we are going to try and teach the algorithms to learn whether a loan is bad or not. So all you have to do is select that target. You'll again get a quick visualization of the split between the true values and the false values, because if there is a lot of imbalance, you need to again go back and collect a different data sample. So what you can then do is very simple. You can select some modes to start modeling, or you can add secondary data sets from another source. So you can combine multiple data sets here as well, so that the tool can actually generate additional features, right? So and you can also do time-aware modeling. So this is a special feature where if your data set has time-aware features like dates or times, you can do a special kind of modeling for those kind of data sets and use cases. Of course, if you're an advanced data scientist, you don't have to hold back your creativity. You can actually go and fine-tune the various aspects of a modeling process. So very like you can fine-tune almost everything that you see here. But if you are an analyst who's just starting and then who's trying to experiment, you would just choose the quick modeling model and then click start. So what it does now, it does some more exploratory data analysis. It analyzes what kind of pre-processing steps need to be done for each of these variables, etc., etc. So it's going to go through these steps, which you see on the right side. Again, in the interest of time, I have it prepared. So at the end of that process that you saw, you will get a leaderboard. This was inspired by the competitions on Kaggle, where people compete and then certain teams have a higher ranking than the other, and then you have a winner. So it was inspired by that competitiveness which we see on Kaggle, and you can see that this software has actually tried various techniques on that data set. So this is not random, it's based on some experience, but you can see that you have all kinds of models like open source models, proprietary models. You can also see some deep learning models that have been tried. So it's a very quick way of experimenting with different techniques. So it's not just algorithms, but if you look at the leader of this pack, which has the highest, let's say, accuracy based on the validation data set, you can see that the software also tells you how the pre-processing has been done. You can even change the pre-processing technique. So you can do copy and edit and then change the steps here, but we're not going to go into that. But this is the differentiator with some other auto machine learning tools, right? So many of the auto machine learning tools out there, they do not offer this kind of transparency. They basically, you feed them the data and they produce a model, and then you do not know how the model has been created. So that's the thing here. You can also do a lot of evaluation. So if you're an expert data scientist, you want to look at the technical charts, or if you're not so expert data scientist, you're just an analyst, you can also try and understand the data set. So here you can see that these are the features that have the highest impact on the prediction. So annual income, for example, which is very obvious, a person with a higher annual income is going to have less chances of defaulting on a loan or vice versa. But you can see the list of features that have the highest impact. Now, what this means is that if you see that certain feature is very important, you can actually go back to the data preparation stage, use a data integration tool like Pentaho, and collect more information on these features. So rather than spending months on data engineering, if you just experiment faster with this kind of a software, you will save time on where you spend time engineering your data sets and data sources, right? So what Andrew Ng, who is one of the leading figures of AI, he says if it takes 2 hours to do the modeling, you should spend 2 days to find and prepare the data. So that's the thumb rule there. And so that's the recommendation I have as well. There are lots of features here. So for example, you can create a compliance report. So if you're a banking customer, you don't need to type in all the compliance steps. You can download this template and then you can edit the template. So you might, of course, have to add more documentation, but you already have, let's say, 60, 70% or 80% of the work done here. And then there are lots of other evaluation options. I mean, I'm not going to go deep into that in the interest of time, but let's say the model is ready. What you have to do then is just go to the predict feature, deploy, and then you just click on this button, and then it deploys the model inside the platform. You can also deploy the model outside of the platform. So we saw like we have manufacturers in this meetup. It might be that you wish to deploy the model on an edge device, or you might wish to deploy it on a Kubernetes cluster. There are other possibilities, but the simplest option is to just click on this and then deploy it inside the platform itself. But as you can see, there are other options as well. So you have to just disable this and click this orange button, and then you have a deployment, right? So I'm not going to do that, but I'm just going to go to the screen, and what happens is like you have a deployment here, which I have done in the past. What you can do now is you can create a job definition, which sort of helps you make the prediction. So you can take the source data, it can be certain data source. You can make the predictions, and when you make the predictions, what's important is that you can select if you need prediction explanations or not. So you can select that, and then you can choose the output as well. So let's say you take the data from a certain data mart table, you either output the predictions into the same table or a different table, and when it's done, what you can do is you can use those predictions and the prediction explanations in dashboarding tools like Tableau or Power BI or CDE or any sort of dashboard. So these data points are not coming from the software, but it's coming from the database, which is or the data mart that is behind the scenes, right? So you can create all kinds of visualizations in any kind of tool. So there are some Tableau visualizations here, but you can also use Power BI, for example. So then you can use the predictions in a different way. For example, this is a use case where you predict the readmission probability of a patient, and then you can see whether changing the care provider has an impact on the readmission rate of patients or not. So that's kind of one of the use cases that you can create. But what if you want to just create an application and then let the user test it themselves? That's also possible. So we have an application builder. You can create all kinds of fancy visualizations, but not to the grade of Tableau or CDE. It's a very simple visualization technique, visualization feature. But what you can do is like quickly prototype and see if that makes sense to put this model in production. So what you have to do is just click, enter the values, so you can populate the averages. So this end user can actually enter some values, click add, and then the software will actually make a prediction on that value. And then you can see, like for example, in this case, the software made a prediction that there's 11% chance of this person defaulting on a loan. And what is important is that you can also see the explanation for this prediction, which is not really the case in many of the other software providers that you see out there. So based on this, you can make a very good judgment of whether or not this model can be put in production. Right. So that's basically the short demo I have. But also, I would like to bring another screen here. So in the end, when you have a lot of models in production, this could be on the platform or outside the platform, you can actually monitor them for certain things. Like, for example, you can monitor them for drift, or you can monitor them for accuracy. So if you click on this one, you can see why the drift is high. So a certain feature in this deployment is highly important and is experiencing a lot of drift. What that means is that when you train the model, you used a certain data set, while the data that is now incoming for predictions is very different from it. So what you need to do in this case is you need to go and retrain the model. And of course, we have a lot of options for retraining the model. So you can do this automatically or on a schedule as well. What I will also show is how Pentaho can be integrated. So what we saw now is me doing everything via the GUI, but we also have a very good API for all of those functions. So whatever you saw I did with the GUI can also be orchestrated with the API. So I don't have any fancy transformation to show, but there's a simple transformation where I take the input data, I send it to the prediction API, and then you'll see that the prediction API returns the results, and then you can store that prediction anywhere you like. So this could be really useful because the data that is sent to the prediction API has to be in a certain format. It has to match the training data set, and this is not always the case. So that's why you need a tool like Pentaho to kind of bridge the gap between auto machine learning or a machine learning platform and the data sources and the data integration possibilities that you have. So that's basically the thing. I have a few more slides. Stefan, do I have the time or should I end the presentation?
Maybe we have maybe 2 or 3 minutes left. So
okay, so just the idea of how so we spoke about data vault before, but there is also the concept of a data mesh, right? So I have kind of visualized how the AI or the machine learning teams can actually be conceptualized in such a framework. And so what customers have told me is that they always want these tribes, as I call them, inside their data product. So you have a data product, and they want that the machine learning teams are working inside this framework. So because there's another possibility where you can have a central team doing data science, but what I see from the field is that customers actually want them to be embedded in their data products itself. So that's there. I mean, we discussed the concept of MLdev and MLOps. So you have to develop the models, but also deploy them. And there's a process for doing this. So we saw how you can scope the project. The data part is where you need tools like PDI, and plus we have a lot of pre-processing that can be done automatically. You saw the modeling phase, and then I gave you a brief overview of the deployment phase as well. So I think with that, I will end the session, and then I will leave the contact slide here. So if you have any questions, I mean, of course, you can reach it-novum and they can reach me. So that's, I think, the best way to interact if you have additional questions or if you are interested in learning more.
Okay, thank you, Bishu. So yeah,
so very quick.
Take the requests and we will answer them. Yeah, does anybody have a question to Bishu? So please write it in the chat. So maybe as a short wrap-up, we are having a look at the combination of Pentaho and DataRobot. You showed the transformation where the data is prepared, and then you're just calling the API, passing over the data to DataRobot. All the magic is happening, I would say, and then the results are returned. So you can really integrate it in your flow, in your data flow.
Yeah, so we saw only the prediction side, but you can also integrate it on the training side, like because you might want to do the retraining based on the schedule of your pipeline. So it might be a daily retraining that happens. So when new data comes in, Pentaho kind of ingests that data, calls the DataRobot API, retrains the model, gets the prediction. So yeah, I think Pentaho can be used, or Pentaho can orchestrate all the functions that you saw that I did with the UI.
Yeah, very powerful combination for my understanding. So that's really, really great.
And especially we saw in manufacturing, right? The heavy lifting is needed on the data integration and the data cleansing side, or let's say the data is produced in JSON or XML. The tool that I showed you is not really capable of ingesting it directly in there. So you need a lot of transformation, especially in the manufacturing sector, to make the data ready for,
data prep upfront, and so that you can feed the algorithms and models with good data.
Yeah,
it makes a lot of sense to me. So I don't see any other questions in the chat. So if there are any, we will answer them later. So again, thank you for the presentation. Well, this was really, really good. Thank you, Bishu.
Thank you. Have a nice day, guys.
Yeah, you too. Thanks. So, dann kommen wir so langsam dem Ende des diesjährigen Pentaho User Meetings näher. Eine Sache, die uns aber sehr wichtig ist, ist einfach auch das Feedback von Ihnen als Teilnehmer. Das heißt, meine Kollegen, die werden jetzt gleich noch einen Umfragelink posten, und wir würden uns einfach sehr freuen, wenn Sie uns da Feedback geben, ob Ihnen die Veranstaltung so gefallen hat, ob Ihnen Dinge gefehlt haben, ob Sie andere Themenschwerpunkte haben möchten. Dann wollen wir das gerne wissen, um die nächsten Veranstaltungen entsprechend ausrichten zu können. Ansonsten, der Herr Herbrich, der hat auch von den 5 Minuten für die Werbung genommen. Ich nehme mir mal 1 Minute noch raus am Ende, um ein bisschen Werbung zu machen. 2 Dinge. Eine Aktion, die gerade läuft, für alle die vielleicht nicht wie die Blechwaren Limburg oder die KR Design eine Enterprise Edition nutzen, sondern auf einer Community Edition aktuell unterwegs sind. Und dann vielleicht auch damit liebäugeln, auf eine Enterprise Edition zu wechseln. Kontaktieren Sie uns gerne. Aktuell ist ein günstiger Zeitpunkt. Da können wir Ihnen aktuell einfach ein gutes Angebot machen, um diesen Umstieg zu ermöglichen. Also da, wie gesagt, einfach gerne hier an die Kontaktdaten schreiben, dann können wir das besprechen. Der zweite Aspekt, wenn Ihnen Daten-Events gefallen und Sie gerne davon noch mehr möchten, so ähnlich wie das, vielleicht zu anderen Themen, dann kann ich Ihnen auch noch ein paar Veranstaltungen von uns in der näheren Zukunft ans Herz legen. In der kommenden Woche, auch gemeinsam mit Hitachi, zum Thema Datenkatalog, wird es ein Webinar geben. Dann sind wir in Frankfurt auf der Data in Motion Tour, und wir haben auch in der kommenden Woche noch ein Meet and Eat. Das ist auch eine bekannte Veranstaltungsreihe von uns zum Thema IoT. Und im Oktober sind wir noch auf dem TDW Virtual und werden auch über Data Mesh berichten oder präsentieren. Das wurde eben gerade auch schon mal entsprechend angeteasert, dass das aktuell ein sehr, sehr großes, wichtiges Thema ist. Alle Termine, alle Informationen gibt es bei uns auf der Webseite. Wir würden uns sehr freuen, wenn wir uns da entsprechend nochmal wiedersehen. Ja, und dann kann ich mich am Ende nur bedanken für Ihre Zeit, für Ihre Aufmerksamkeit. Ich kann mich bei allen Referenten bedanken, dass Sie Ihre Vorträge hier vorbereitet und hier durchgeführt haben und bei dem ganzen Organisationsteam, was das immer wieder möglich macht. Hat uns großen Spaß gemacht heute. Ich hoffe Ihnen auch und wir freuen uns drauf, Sie dann im nächsten Jahr wiederzusehen. Herzlichen Dank und schönen Tag noch. Machen Sie es gut.